Hi everyone! Factoring integers. Yeah, that's what I said. We're going to do that. We're going to factor them. The objective to factor integers to find the GCF. Yeah, yes, of several integers, man. Alright, well, to factor. What do I mean when I say factor? Well, when I factor, I say, what I'm trying to do is to write a number as a product, man. Yes, I said it, a product. So I take a number, for instance 36, and I write it as a product of 9 and 4. I factored it. Bada bing, bada boom. Does it have to be 9 and 4? No, I could have chose 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6. Any of these factor pairs. As a matter of fact, I could have been crazy and done -1, -36, -2, -18, and chose of any of these products. Either way, I factored 36. That's what factoring is. So, sometimes we're asked, when we're asked to list all the positive factors of a number, we can use what I call U factorization. It's a U shape. U shape. You'll see what I mean in a second. I call U factorization. I call it because it lists them in a U shape. I start with the lowest factor of 48, which is 1. 48. Then I say, does 2 go in? Oh, yes, it does. 2 goes into 48 24 times. Does 3 go into it? Yes, 3 goes into it 16 times. I say, does 4 go? Oh, yes, 4 goes into it 12 times. 5? No. 6? Yes. 6. 8 times. Is 7? No. 8. And what if I get to 8? Notice I'm over here. And then the next factors I'd find would be 12, 16, 24. So I found all the factors. That's my little U right there. Now those aren't all the factors, pairs of 48. These are just all the positive factors. Suppose I said list all factors. Well, then I'd also have to list all the opposites too. But since I'm asking just for the positive factors, here are all the positive factors. But there's another factorization sometimes you're asked for, and that's called the prime factorization. When you're asked to find the prime factorization, we want to break a number down into its smallest components, its prime factors. Prime numbers are the building blocks of the integers. Okay, think of prime colors. You know, prime colors are the colors that build all the colors. Well, prime numbers are, the building blocks of all the integers. Primes are integers greater than 1 that have no positive integral factors other than itself and 1. Basically, it has 2 positive factors, itself and 1. Examples of primes: 2, 3, 5, 7, 11, 13. These are all primes. There's no factors except for, there's no positive factors except for 1 in themselves. 1 is not a prime number. 2 is a very special prime. It's the only even prime. Now, let's find the prime factorization of 48 here. Well, 48, well, this is easy. What do? We break it down. We use what we call a factor tree. 48 is 6 times 8. Very nice, very nice. I can break 6 down further to 2 times 3. I can break 8 down to a product, 4 times 2. Am I all done? Well, and 4 goes down to 2 times 2. I use a tree, so I take this 48 and I split it to a product, 6 times 8. Then I say, can I go further? If I get to the end of a branch here in this tree, I end up getting a prime number. If I get to the end when I can't break it down any further. 4 keeps going, but 2. These are all the branches. These are all the factors. I get 48 is actually 2 times 2 times 2 times 2 times 3. And we can write that in exponential form as 2 to the 1, 2, 3, 4, 4th power times 3. So there, I've factored it using my factor tree. Whee! Now, special factors of 2 numbers. Sometimes we want to find this thing called the GCF. It's the greatest common factor. It's the biggest common factor. It's the biggest number that goes into both numbers. So basically we might be asking, what's the largest number that's a factor of both? For instance, 24 and 18. What's the largest number that goes into both of these? To find these things, we can look at the prime decomposition of each number, meaning we can break them down to their factors and see which ones go into both. Now, when you're looking at this, you say, let me see, 18 doesn't go in. What's the next one? 9, no, 6. I bet you're thinking, maybe 6 is it. Well, we're going to find out by doing a little thing using a Venn diagram and some stuff we learned about set theory. So, for instance, we have the numbers 24 and 18. I want to break it down. I want to do this prime decomposition, meaning I want to break this down to its prime factors. So I'll use a factor tree. 12 times 2, 3 times 4, 2, 2. And I find out that 24 equals 2, 2, 2, 3. 2, 2, 2, 3. Or, I can write down here, 2 to the 3rd times 3. That's going to be my 24. Now 18 I'll break down. 2 times 9, 3, 3. 9 is 3 times 3. I get 3, 3, 2. So I'll write this as 2, 3 squared. So I look at them. All right. So this guy I have a 2, 2, 3. This guy I have a 2, 3, 3. And I look, do they have anything in common? Well, if these were sets and I was going to put their elements in this Venn diagram, wouldn't I put a 2? They both have a, this guy has a 2 and a 3. This guy has a 2 and a 3. The most they share is a 2 and a 3. So wouldn't you put those in the middle here like we did with set theory, the 2 and the 3? And what's left over here? Just a 3. What's left over here? A 2 and a 2, or a 4. And I just double check. This number in here, 2 times 3 is 6. Yes. 6 times 4 is 24. 6 times 3 is 18. So I found this guy in the middle, the shared part. Should have made that a little bit bigger. So let me just try to fix this so you can see it better on the video. Let's bring this guy in like this. And so this was 2 and 3 were the guys that share. Well, 2 times 3 is 6, right? So really they share this factor, 6. Well, that number that you put in the middle there, that is the GCF. There's another way you can figure out the GCF when you're looking at prime decomposition here. Here we go. We have 2 times 2 times 3, 2 times 3 times 3. We say, all right, we look for the most pieces that go into both. So they both have 2's and 3. What's the most 3's that go into both? Well, there's 1 3 here and 2 there. So they share just 1 3. So what do they share? They share 1 3. What you're really looking for is the smallest exponent of both. But we'll you know. And then look at 2. What's the most they share? The 2, the smallest. Okay, 2 to the 1. All right. So basically, look for the smallest exponent that they have, you know, of factors they have in common, and you get 6 either way. So for instance, let's do it here. GCF of 60 and 36. Well, we get 6, 10, 2, 3, 2, 5. Right. Here we have 6, 6, 2, 3, 2, 3. Okay. So here we have 2 squared times 3 times 5. Here we have 2 squared times 3 squared times 5 to the 0 I'm going to put it because that number's 1. And I'm going to say, all right, what's the smallest? You know, here's all the factors written out so I know what's the smallest one they share. So they share no 5's. The smallest 3 is 1. 3 to the 1. The smallest 2 is squared. 2 squared. So what do they share? The greatest common factor is 3 times 4 is 12. That's the greatest number that goes into both. The other way we could have done it is if we set up our Venn diagram here. We would have noticed that they do share what? A 3 and a 2 and a 2. That's what they share. A 3, a 2, and a 2. A 3, a 2, and a 2. What's left over here? Just a 5. And that's an ugly 5. Oh, so that's a 3. Sorry. What's left over here? 3. And that's left over on the other side. And 3. And what's left over here? 5. And it would look like that. Alright? And finally, if you're asked to list all the factor pairs of this, negative 32. So we're going to factor 32. Let's see, negative 32. We have negative 1. 32. Negative 2. 16. Negative 3. Negative 4. 8. Negative 5, negative 6, negative 7. There they are. But I also have the partners are the opposite of these. The opposite of these guys. 1, negative 32. 2, negative 16. 4, negative 8. So those are the factors pairs. And finally, you might be asked to find the GCF of something like this. A squared B, AB squared. So we factor this guy out too. A squared B, right? Does that make sense? Factor this guy to AA. Look at this guy. Factor this guy AB squared, BB. You end up getting this guy again. So what do these guys share? What's the most A's they share? The most A's they share. What's the smallest exponent of the share? Let's see, it's A to the 1. What's the smallest B? B to the 1. So they share AB. AB would be the GCF of these two. And if we did it in our little Venn diagram here, I'd notice they both have an A and a B in common. This guy has an extra A, this guy an extra B. Double check B squared A. Yep. A squared B. Yeah, so this is still A squared B. This is still B squared A. Hopefully you got that. Have a nice day.